Hello friends, so today we're going to discuss this question from April to COP 2020 matrix decomposition. This is the second question in the contest. The question statement states that you are given a square matrix M with n rows and n columns. Initially all the elements of the matrix are starting, the matrix has all the elements equal to A, and the matrix is broken down in n steps from 1 to n. And in each step, some of the elements of the matrix are simply marked as removed, but all the elements are still indexed in the same way and the original matrix. And what we have to do is, so let's see with this example. So let's first complete the question. We have to take these elements and remove it, take these elements and remove it, and let denote all these elements. The product of all these elements is 2i minus 1 elements, which represent as pi. So each of these remaining elements of the matrix is multiplied by pi. So this is the multiplication of all these elements, and the rest of the elements are multiplied by this pi. So we have to find out the sum of all those pi's, and as it is very large, you have to modulo it with 10 to the power 9 plus 7. Okay, so let's see with this example. So what we have to do is, then in this given there are n matrix, the rows and columns are n. Okay, so the rows and columns is a 3 by 3 matrix and it is initialized by 2. Okay, so we have to remove the elements in this fashion. First this top right block cell, and then we remove this, the next matrix look like this. So we remove these 3, then the matrix look like this, and then we remove these 5. So as you can see, this is an odd series 1, 3, 5. So this is our first observation. Now as you can see, the first element is 2. Now when we remove 2, we multiply it with every remaining element, so all the remaining elements become 4. Now we do a multiplication of all these, because what we do is we take this 2i minus 1 elements, it represents odd number of elements, and as we can see there are odd number of elements. So we multiply, or we do the product of these elements and we mark it as pi. So the first pi is the original number 2, then the next pi is the product of all these numbers. Product of all these numbers is 4 into 4 into 4, which is 64. So now 64 is multiplied with all the rest of the numbers. So 64 into 4, it becomes 256. So now 256 is multiplied this 5 number of times, and all these numbers 2 plus 64 plus multiplication of all these numbers is printed modulo 10 to the power 9 plus 7, and this is the final answer. I hope you first understand the question statement. So what we do is, as we know, this number is initialized, so the total sum or final sum is actually, the first pi is the A, which is input, so it's equal to 2. Now we know the series, because it occurs one time, the next occurs 3 times, so we make an odd series of 2i minus 1, and I ranges from, its first is 1, I is equal to 1 first, then I equal to 2, when I equal to 2, it is equal to 3, this value. So it means there are 3 elements. So what we have to do is, this, what is the current element at the outer state, we have to do the power of that number 3. So 4 power 3. Then what is the, then we multiply this 4. So this is 64. So we have to store this number. This is equal to 64. So we have to store this number. And for the next number, we have to multiply it. So now it becomes 256. So we have to multiply 64 by 4, and that becomes our next number, 256. And what is the power of it is I is equal to, we put it 3 here, it's 5. So 5, so we put the power of 5. 256 and multiply 5 times. And we have to add all these numbers, and that will give our final answer, and we have to give the model. That's the simple logic. So let's write down the code for it. We have to just properly use the modulo functions here. Okay, so first we take long n and a, and we input n and a. Now what we do is we initialize answer to a, because we know that a is always present in the, which is the first value. Okay, now what we do is, as we have stored answer, now we have to store b. So what I have stored b is this value, like, which stores 4 to 56. The first outer value at any state is b. So because we have stored 2, now our outermost value is 4, which is 2 into 2. So it's a into a. So our outermost value of b is a into a. I hope you understand what I'm doing here. And then I'll make a power pp to, which is initialized at 1. You will later see why I'm doing this. So now I'll do a for loop from I equal to 2, because we have stored the first value, and we have to move it to I equal to n. Now what we have to do is, we have to first find out what's the power. So power is actually the odd number. So the power we can calculate by this formula, 2 into I minus 1, which I've told you earlier. Then we will find out what's the b value. B value at this state is this, but as it progresses down, the b value is b mod into power mod whole mod. So what I'm doing here is, actually we know that power represents the final value, 4 to the power 3. So we have to multiply 4 to the power 3 into 4. So 4 to the power 3 is 64 into 4, which is b. B represents the this value, the outermost value, and pp represents the power value, 64. So we have to multiply 64 into 4, and that's our new cell value. That's our new b value. So that's what I'm doing. A new b value is the original b value into the power value. Now we have to calculate our power. pp is equal to, we write a function because it's becoming very big. So we have to write another function in which we have to give the power of b to the power of n. Num stores the odd values at that state, and b is the outermost value. So we have to give 4 to the power of b, as you can see, 4 to the power 3, 256 to the power 5, and then answer is equal to answer mod. I have to add the power value, because in the final answer we have to add the final power values, 2 to the power 4, 2 to the power 15, 256 to the power 5. That's our final power value. You have to add it in the answer, and okay, and we have to return out our answer mod this. Okay, so now we have to write out some couple of functions and mod value also. So constant long mod is equal to 1e9 plus 7. and we have to also write out the power function, which is we have to return a long. We are inputting like b to the power of p. So I hope you know how to write this power function. So we take a variable r1, do a for loop, p, then we increment multiply b is equal to b into b mod comma p is divided by equal to 2, and if p is odd, we have to return, we have to see r equal to r into b mod, and at final we have to return r. That's the code. So that's the power function. So in the power function, I hope you know how to write the power function. So let's say we have to find out 4 to the power of 6. 4 to the power of 6. So what we do is 4 to the power of 6, to find out 4 to the power of 6, we like divide this into 4 to the power of 3 and 4 to the power of 3. And if it's an odd, we do it in 4 to the power of 2 and then 4 to the power of 1. That's what I'm doing here. So let's copy the test function. It's 132 and yep, it's given the correct answer. So let's submit it. I hope you understand the logic what I'm doing here. So it's giving the wrong answer. Let's see what's like done wrong here. So yeah, actually we are not returning it in printing in different lines. That's the problem. So it's now read. I hope you understand the logic what I'm doing here. If you still have any doubts, please mention it in the comment box. I'll try to rectify it as soon as possible. If you like this video, please hit the like button and it's give me a very much motivation. Thank you, and I'll see you in the next one. Bye.